All right, so welcome back. This time around, we are going to look at the regulation of pyrimidine biosynthesis. In the previous video, I have walked you through the entire pyrimidine biosynthesis pathway. Very simple pathway. Now, right here, I just have a simplified form of it. You can see our glutamine plus CO2 plus 2 ATP basically give us carbomoy phosphate. Sorry. From carbomoy phosphate, I got what carbomoy aspartate. Then I got what? I got orotate. I think there was actually dihydroorotate first, but later on we got orotate. From orotate we got what? UMP. From UMP, we got OMP. From OMP we got what? UMP. When we lost the carbon dioxide, Abi, was it the carbon dioxide we lost? Yeah, it was the carbon dioxide. When we lost the carbon dioxide, we got UMP. From UMP, we got UDP. Last, at the end of the day, we were able to get CTP. I'm not showing TTP now, but I believe you remember this pathway basically, okay, from the last video. All right. Now, this one, what I want to show here is the regulation. Notice that for this place, focus on this place. Are you seeing this place? The enzyme that convert OMP, the enzyme that convert OMP, the enzyme that convert OMP to UMP. You remember that enzyme? The enzyme is called what? OMP decarboxylase. I get my point. OMP decarboxylase. That enzyme is under feedback regulation. That is one. Then two, this enzyme at step one here. This step one enzyme here. This step one enzyme is also under feedback regulation. In fact, this enzyme is the rate limiting enzyme. And I believe you know this enzyme. This enzyme is called CPS2. CPS2. Carbomoy phosphate synthetase 2. You can see it here. Hope you can see it. CPS2. So this CPS2 together with OMP decarboxylase in step 6, they are the enzymes that are under feedback regulation in the regulation of purine. All right, focus on this one first. Focus on this. Now, OMP decarboxylase is under feedback regulation by UMP. Are you seeing this UMP here? This UMP can inhibit it. So that's why I put this minus sign here. UMP can inhibit it. At the same time, CMP can also what? Inhibit. What is CMP? Cytidine monophosphate can also what? Inhibit it. So that is for that. That's how we inhibit this one. I will say it again. UMP and CMP. In fact, the monophosphate are what is inhibiting this step. Take note. Are you seeing it? All right. Then, if you should move further, once I'm done with the regulation of this step, come now. This one that is triphosphate, this UMP triphosphate, can inhibit this step one. So UMP triphosphate, UMP that is UTP, uridine triphosphate, UTP, can inhibit within the step 1 enzyme. Is that not so? Then again, what can now stimulate the step 1 enzyme? High levels of ATP and high levels of within PROPP. Can you see it now? So you can see that in this entire thing here, there are two main things you have to get. One is the OMP decarboxylase enzyme, what regulates it. Two, the CPS2 enzyme, what regulates it. For the OMP decarboxylase, what regulates this one? Is it not your UMP and CMP, right? Both of these two will inhibit this enzyme. That's also good. How about this step here? For this step here, what inhibits it? This UTP inhibit it. Then what activates this step? ATP and PROPP. All right. So that is for that. This is all about the regulation of pyrimidine biosynthesis. The main thing you need to know is this particular enzyme, OMP decarboxylase, how it is regulated and how this one is also regulated. Very simple. For OMP decarboxylase, know that it is the monophosphate that is inhibiting it. While for this one, it is the triphosphate that is inhibiting it. Then also this one is also stimulated by ATP and PROPP. You understand? All right. Thank you. In the next video, we are going to look at some diseases under pyrimidine. Or we'll look at the breakdown of pyrimidine first.